Hello everyone. This video is the fourth in our series of constructing filters using the Cubro Packetmaster line of network packet brokers, and the second specifically pertaining to filtering on VLAN information, this time using the CLI of the Packetmaster, or the command line interface. If you haven't seen the video previous to this one, we used the GUI to filter based on VLAN information, and I'm going to be trying to follow the steps presented in the GUI video as closely as possible here in the command line video. So I recommend you check out the GUI video just for that purpose alone. And also in the GUI video, I use a packet capture of known traffic to demonstrate the filters and how they affect the traffic going through the Packetmaster. I won't be doing that in this video, just in the interest of time and not repeating some things that we've already seen. I'm simply going to be presenting the syntax that we need to accomplish the same filters we used in the web GUI here in the command line interface. So let's go ahead and get started with that. In the GUI video, we saw that by default, every rule starts with a VLAN option checked to matching all traffic, be it tagged or untagged. In the command line, we really don't have any such option. If you remember our last command line video, we were doing basic flows, forwarding flows, just getting traffic from one point to another. And we saw our ccadd flowbridge 0 command in that, along with specifying our inputs, our priorities, and our actions. And so far, the only action that we've really looked at is the output action. But this is all you need to also send or forward all traffic, whether it's tagged with VLAN information or not, out to your egress interface. As long as if you don't specify any particular filter pertaining to VLANs, then you're going to get all traffic, whether it's tagged or not. So that's all we need to match all tagged and untagged traffic. Now, if we want to match tagged traffic or untagged traffic, and likewise leave the inverse out of the equation, then we're going to actually add a parameter to this. We're going to add the VLAN underscore TCI parameter. And to match all untagged traffic and ignore any VLAN tagged traffic, we're going to give this a value of 0x0000 /0x1000. So this command with this additional parameter right here is going to only match untagged traffic. If we want to match only tagged traffic and all VLAN tagged traffic, not just specific VLANs, then we can do that using that VLAN underscore TCI command again, but we're going to change our value for that to a 0x1000 /0x1000. So this is matching all tagged traffic. There's another command that's slightly shorter that will also match all tagged traffic. It basically is the same thing as this, it's just a bit of shorthand. And that is going to be the VLAN underscore TCI equals 0. And that's the only value that you need. This will match all tagged traffic and not pass any untagged traffic. Now, if we want to filter on some specific VLANs, then we're going to need a different parameter in there. So let me just clear out our flows so that we can later take a look at what we're adding in here. So this is going to be the DLAN or the DL underscore VLAN parameter. And the value you're going to give for this is simply the value of the VLAN ID you want to filter on. So in the web GUI video, the first VLAN that I filtered on was a VLAN of 5. So here I could just throw a 5 in there. DL underscore VLAN equals 5. This rule is going to pass all traffic with a VLAN ID of 5. You can also specify these values in hex, just like we showed in the web GUI. So if you wanted to filter on a VLAN of 100, and for whatever reason you chose to put that value in as a hex value, that would be 0x to specify we're using hex, and then a 64 for 100. So if we dump our flows here, we see the rule where we added a VLAN filter of 5, and then we also see our DL underscore VLAN equals 100, and it's getting this value from the hex value I gave it up here. If we want to filter on multiple VLANs at a time, in the web GUI, we were able to specify multiple VLANs in one shot by separating them with commas, and we were also able to specify a range of VLANs by separating the values with a hyphen. Much like we saw with ports in the GUI versus the CLI. In the CLI, we cannot specify those ranges. So if you want to filter on multiple individual VLANs, you just need to construct a rule for each of those VLANs. So in the web GUI, I did a filter where I filtered on both VLANs 5 and 32. If I wanted to do that in the command line interface, I would simply create one of these rules, one for 5 and one for 32, and that would accomplish the same thing. As far as a range goes, we actually can, in a way, specify a VLAN range to filter on, and I'll come back to that at the end of the video. It's not what I would consider the most user-friendly way of doing things, but we certainly can do it. Okay, so if we want to filter on our VLAN PCP or our priority code point, we can do that as well. That's going to be a parameter of VLAN underscore PCP, and then whatever the PCP value we want to filter on would be, like 7. We can throw that in there, and this would filter on all VLAN traffic with a priority code point of 7. And we can combine this with our DL underscore VLAN parameter to now filter on a specific VLAN, like VLAN 100, and then only packets that are tagged with a priority code of 7 in VLAN 100. So you can certainly combine those things. Now I want to come back to that VLAN underscore TCI command, because we can do some interesting things with that. What we're actually doing with the VLAN underscore TCI command is we are specifying the entire tag protocol information, or I'm sorry, tag control information. So when we do this, as we saw up here with the 0x, we're actually specifying a hex value. And what we're really doing when we filter on tagged and untagged traffic is we're specifying a match value with a mask. And I'll explain the mask part in a bit, at least to the best of my ability. Let's start with just the match value. So if we do VLAN underscore TCI equals and then a 0x to show that we're using hex, this is comprised of 4 fields, or 4 values, 4 hex values. This first hex value is where you're setting your PCP, and actually the lowest value that this can have is a 1. And what that's doing is it's actually forcing the DEI, also known as the CFI, the drop eligible indicator, to a value of 1. This is the lowest value allowed in this first field. The rest of these 3 fields are to specify our VLAN ID. So if I wanted to filter on a VLAN ID with any priority code available, I could do a VLAN underscore TCI value of 0x100A. And then if we dump our flows, we'll see that by doing that, I actually specified a VLAN of 10 and a PCP value of 0. If I wanted to filter on a PCP value of 7, then this first value would be an F. And let's say I wanted to do a VLAN of 20. This would be a 0xF014. So the one value here gives me 16 plus 4, that's 20. And we see that right here. So we've specified VLAN ID of 20 and a PCP of 7. So, so we're not at each end of the spectrum here. We could do a VLAN of 7. This is actually going to give you a PCP of 3. So the way that I found that it works is at 1, PCP of 0, at 3, a PCP of 1, at 5, a PCP of 2, 7, 3, B would be 4, E would be 5, or I'm sorry, D would be 5, and then F would be 7. And then maybe we want to do, a VLAN of 15 would then be 0F. So if we dump those flows, we see our DL VLAN equals 15 with a PCP code of 3. Now, is this really any faster or easier than specifying the DL underscore VLAN and the VLAN underscore PCP parameter separately? I don't think so. hex values are not something that I can pop off the top of my head and just come up with. But if you're one of those people where hex just comes naturally to you, rock on, use this command to your heart's content. And you'll really dig this next part where we do the masking. So we can combine these values with a mask to filter on a range of values. So for example, if I do a 0x100a, this is going to construct a filter where it's going to match all priority codes of 0 that are in VLAN 10. But if I mask this, and the way the mask works is any bit value where the mask has a 0 is going to wildcard the match we specified. And if your mask would have a bit value of 1 for the value of your match value, then you're going to have a strict match on that. So if I do a 0x1 and then an FFF for my mask, what I'm doing is I am wildcarding everything above this 1 value, because those would all have a 0 in the mask. And I'm doing a strict match on this entire section of the match. So I'm doing a strict match on the VLAN ID of 10. And the result of this is that I'm going to filter out VLAN 10, but I'm going to filter out every priority code. So this by itself is VLAN 10 with a priority code of 0. With the mask, this is a VLAN of 10 with any priority code, which kind of shows in a way this is not the best example for efficiency, because specifying DL underscore VLAN equals 10 does the same thing as this. But just using this to build our example, if I then say substitute this last F for a 0, I have a strict match on these fields, but I have wildcarded this value now. So in hex, 16 values, that's VLANs 0 through 15, but I still have a strict match on the DEI, and I've wildcarded the priority codes 1 through 7. So this is going to result in me getting a range of VLAN 0 through 15 and all priority codes. So this is a way that we can do VLAN filtering by range in the CLI. And we can actually see that if we dump our flows, we only see our masks, so this doesn't really tell us a whole lot. However, if we go into the web GUI, we can see that this gave us a range of VLANs right up here. And for my final example there would be if we wanted to filter on a strict priority code inside of a range of VLANs, then we could change this first value to a 7 and then also a 7 here in the mask. So we have a strict match on this. This is priority code 3. Strict match, still a wildcard on this value. So a strict match of code 3 on VLAN 0 through 15. And that's what that rule would produce as its output. And again, we can see that in the web GUI right here. So again, maybe not the most user-friendly thing in the world. It certainly isn't in my opinion, but it is an option that we have in the command line, so it's worth showing for anybody who cares to use it. Apart from that, this covers setting up the VLAN filters inside of the command line interface. And in the next video, we're going to be moving on to filtering source and destination MAC addresses in the web GUI. So until then, thanks for watching, take care everyone, and have a great day.